just give you the instructions also. You can keep the instructions. Okay, so this is the data sheet. There's those. And this is the data sheet. So this lab is the titration lab. How many of you have done the titration before? Maybe chemistry before? Okay, this is Okay, we are going to talk about what a titration is, and I'm going to demonstrate the titration for you, and then we'll do the pre-lab. I think that will make more sense to do it that way. So this is what you are going to have to do next time. All right. All right, so right now my burette is filled with water. When you go into the lab, your burette will also just be filled with water. So we need to dump it out. So one way is just to like open the end. This also has some parafilm on the end. This is just like some gummy kind of plasticky stuff. And I just have it on here because I fill this with water. If I store them dry, if I don't get it, usually we have base in here. If I don't get it all the way clean, then it clogs up with pieces of base, and then it gets really hard to get the base out because anyways, base reacts with glass. So it makes it hard to work with. Okay, so right now my burette has water in it. I have to take off the cork. I'm just going to dump out the water in the sink. This is just water. If I open the end, it'll go a little bit faster to dump it out. So right now I have a mixture, or I have just like a water in here, okay? So what you're going to be doing is I made some sodium hydroxide solution, and you're going to do two types of titrations. Let's put this up here. The first type of titration you're going to do is a standardization titration. And the instructions for that are written in the instruction sheet. So the first titration, so two titrations. So you're going to do standardization of the sodium hydroxide solution. And you're going to use KHP for this. This is an abbreviation. It's not really potassium, hydrogen, and phosphate. It's a very complicated chemical formula. We can look it up. Let's look it up. So KHP is, and it might be in the instructions. I don't remember. I'm going to look up the molecular weight for KHP. So this formula. See how there's carbon, there's potassium, there's 4 oxygen, the hydrogen. So there's all sorts of. It's not just KHP. Our molecular weight is 204.22 grams per 1 mole. So we are going to need this number later, so keep track of that. So what you're going to do is this chemical, if we look here, it has 1 hydrogen that we can titrate. So I don't know if we talked about this. I think I think chapter 7, we talked about acids and bases, or chapter 8. What we're looking at is hydrogen, the hydrogen ion, plus hydroxide. Okay, I have a hard time teaching when people are talking because I feel like I shouldn't be up here if people aren't listening. So if you could wait to talk till after we're done, that would be helpful for me. Okay, so we have hydrogen and hydroxide, and that gives us water. So this is a 1 to 1 to 1 ratio, and then this is a neutral solution. So what we're doing is we're taking acid, we're adding base, and we're getting something that's neutral. We can test for when it's neutral by looking for a really faint pink color with phenolphthalein, which you'll have in a dropper bottle. Okay, so when we have 1 hydrogen to 1 hydroxide, this makes it so we can quantify exactly how much hydrogen we have, or exactly how much base we have. So what we're going to do is we're going to measure out KHP exactly. Then we can figure out if I have this many grams, how many moles of this do I have? So I'm thinking about exactly how many hydrogens do I have? And then if I have this many hydrogens, it took this much hydroxide to titrate this exact amount of hydrogen, and we can find exactly the concentration of this sodium hydroxide. So I made about 0.1 molar, but you need to check to make sure that I made exactly 0.1 molar. It might be actually 0.9, okay? This lab is quantitative. That means we are trying to get the best number that we can, okay? So that's why we're standardizing. We're saying we have about 0.1, let's see. We have about 0.1 molar NaOH, but standardizing means we're finding exactly the concentration. And we'll do that by we'll find exactly how much H plus is coming from this KHP chemical, and then we'll figure out exactly how much volume we use, and that will help us figure out exactly the concentration. It might not be 0.1, that's the point, okay? So that's the first titration. The second titration you're going to do is you're going to titrate vinegar. So titration of vinegar, and you're trying to figure out the concentration of vinegar. Okay, so you're going to use the standardized sodium hydroxide to figure out the exact concentration of vinegar. Okay, all right, so those are the 2 types of titrations you have to do. You're going to do at least 3 times of this one and 3 of this one to get a good average. This is quantitative chemistry. We want to know exactly how much there is, okay? All right, so let's go back, let's go back to our lab setup. So we've used a burette before a little bit. So this is our burette. Let's see, I might need to move some things. And what we're going to do is, first, the burette still has some water in it. I don't know if you can see that. Right here, yeah. There's a little bit of water. We need to rinse the burette with our base to make sure that everything in here is not water. We need to make sure it's all base. That way we can get the best number possible, okay? If we have a little bit less base in here than we think, that's going to mess up how much the concentration of vinegar is actually, okay? So this one is more particular about how you do the experiment. Okay, so I have an extra beaker here. What I'm going to do is I'm going to pour, let's see, I need another beaker. Let me grab some more beakers. I'm going to pour some base through the burette to rinse the burette. I'm going to rinse the burette with base. All right, so this is my sodium hydroxide solution. I have some parafilm so it doesn't evaporate, so it stays the same concentration. I'm gonna stir it a little bit before I pour some out. Okay, so then this one's going to be my sodium hydroxide. And it's about 0.1, but we're doing the first type of titration to figure out exactly how much it is. I'm not going to do that part. I'm going to do the second part. This one, you're going to do the same thing, and we'll talk about how to do that in the pre-lab. The pre-lab has a question about that. All right, so before I start, I don't have a funnel. I'll get a funnel for you. I forgot I need funnels. So I'm just going to rinse a little bit through. So then everything in here is going to be base. So I'm going to let it drain. And then I cannot pour this solution. Can I pour this down the sink? Yeah, I think this is all okay to go down the sink. All right. If you get this on you, you will want to wash it off. So if you're filling it up and you get some on your fingers, fill it up the rest of the way and then wash your hands. Okay. It's quite strong base. Okay, so I've rinsed it a few times. Now I'm pretty confident that all of the water has rinsed through, and everything that I measure in my burette will now be sodium hydroxide solution. Okay. All right, so next I'm going to fill it up to about 0. Okay. Remember, these are backwards. The number line goes down, so it goes from 0 to 50. I have to be between 0 and 50 to measure. And then remember, we measure this by difference. We write down the initial value, we write down the final value, and we subtract the final from the initial to get exactly how much we actually added to our burette. Okay, so I'm going to fill this up to about 0 without going over. It doesn't matter if it's right at 0. I want to just make sure that's on the line so that I can measure. Okay. So, do you remember how to measure the liquid? It's kind of got this weird, I don't know if you can see that. Can you see that? So where do I measure it from? Good, bottom of the bubble. That's called the meniscus. We're going to measure from the bottom of the bubble. So the numbers are facing me. I'm going to say the bottom of the bubble is, if I align it with there, it looks like it's 0.6. That's where my initial reading is. Okay, so in your data table, you have 2 different tables. So you have things that you need to record. And it has like 6 boxes. I expect you to do 3 titrations for each. Okay? They have extra if you think that you need to do extra. So then there are all the calculations. So in table 2, we're going to do an example of titrating acetic acid. So you're going to record the initial value of the initial volume. So that mine would be 0.6. I'll write it down on here as an example. I'll show you. So this would be, my initial value is 0.6. And then this burette, we get 2 decimal places. So that's something else I'm going to be watching for. Every measurement from the burette should have 2 decimal places, even if it's right on the line. Then if it's right at like 6, then it should be 6.00. If it's right at 0, it should be 0.00. 2 decimal places always. So I'm going to put 0.06 as my initial value. Okay, so I have my burette set up. The next thing that I'm going to do is get my samples ready. So I'm going to titrate in, this is called an Erlenmeyer flask. I'm going to fill my samples up in here. Before I do that, I'm realizing I need vinegar. I'm going to go grab some vinegar. Okay, so this is going to be vinegar. Use this one. So I'm going to take some of the vinegar. The other thing you have to do on your, so look at your data sheet for a minute. You have to write a procedure for titrating acetic acid. We did this lab last year, and so I'm going to share with you the lab book from last year, and you can look at the lab book to get an idea of how to do the titration. And I'm also showing you how to do it. And then you can write your own procedure. Okay. So before you come on Friday, you need to write out what you're going to do to titrate vinegar. I think in the lab instructions, it gives you a background and it also gives you the procedure for titrating the first titration, the standardization of the sodium hydroxide. But then you have to come up with the procedure for the titration of vinegar. So we're going to go through that together. All right, so what we did last year, and I think what will work really well, is you're going to take some vinegar, and then you're going to dilute the vinegar to 100 milliliters. It's really important that we're using glassware that it gives exact values. We want to know exactly how much vinegar or how much acid is in this vinegar, okay? So I'm going to take this is a pipette bulb. I'm not sure we have used this yet. So to use this, I'm going to, there's some little buttons on here. I don't know if you can see. So there's one that says S, there's one that says E, and there's one that says A. So I'm going to take this and hold by the A button and pinch and get rid of all of the air in there. And then I'm going to use the S button, and I'm going to, I think the suck button, I don't know, pull some of the liquid into the pipette. I do not want liquid in the pipette bulb. That makes them go bad really fast. So do not get liquid into the pipette bulb, okay? I went a little bit above, there's a 0 line here. I'm going to, play with these buttons until it's exactly, my meniscus is exactly on the 0 button. And then what I'm going to do is I'm going to take this exactly 10 milliliters and I'm going to put it into this volumetric flask so that I know exactly, so I put exactly 10 milliliters of the vinegar into my 100 milliliter volumetric flask. And now I'm going to dilute it to the line so I know exactly the volume. Remember when we're talking about concentration, concentration is moles over total volume. This is my total volume. Okay, my total volume of this will be 100 milliliters. And I will need to know that I did this when I do the math for figuring out the concentration of the vinegar. This is going to be, once you've done the lab, there's going to be a lot of calculations. If you get stuck on the calculations, let me know. We might take some time to do that in class if we need to do that. Okay, so I'm going to pour my water, my distilled water in to fill up to my total volume. Okay, so I've got not filled up to the line yet, so I'm going to bend down so that my eyes are level with the line. I'm going to fill up till the meniscus is at the bottom of the meniscus is at the line. So I'm right on there. Okay, so then this is my sample that I'm going to use. Now it's a little bit diluted. If you don't dilute the vinegar, then you're going to have to use a lot of base. So watch out for that. Okay, so then I'm going to use another beaker. So this one was vinegar. I need to label these. Do that in a minute. I'm going to dump some of this out, and I'm going to use exactly 10 milliliters of this sample and put it into an Erlenmeyer flask. Okay, right now this is concentrated vinegar. It was dry, so I didn't rinse this out. But now I want to rinse this out. So let's see. I can pour some through. Let's do that. I want this to be my sample. I don't want it to be, if I use it right now, there's going to be extra vinegar in there, and that's going to make my numbers different. They will be higher than the true value. So I'm going to rinse my sample through the pipette. There is also a video of someone at Weber State doing this lab. Well, they did a different lab. They did a lab with, I think, iodine as their titrant. So this is the titrant. We're titrating with sodium hydroxide. Okay, so I feel pretty good about Now this is just my sample, so now I'm going to use my pipette. So I'm going to put my pipette bulb back on. I still have most of the air evaporated from there. And then I'm going to use this S button, pull up the liquid, and then I want it to be right at 0. This pipette can also give us 2 decimal places. So every time I use this pipette and fill it to the 0 mark, that will be 10.00 milliliters of sample. Okay, so right there. I'm going to take my sample and add it to this Erlenmeyer flask. And also, it will leave a tiny amount in the tip. I don't know if you can tell, there's just a little bit in the tip still. These are calibrated so that a little bit stays in the tip. So you don't need to get that out, okay? So I can just stay. All right, so now I'm ready. I have my sample of diluted acetic acid, diluted vinegar. And then I'm going to add 3 drops of this phenolphthalein indicator. So remember we talked about we need the acid and the base to be equal. So when it's equal, this will turn pink. This indicator is clear right now. It will turn pink when we have the slightest amount of base. So we're going to be overshooting a tiny bit, but that's how we're going to tell when we're done. So I'm going to put 3 drops of indicator. 1, 2, 3. I've got my initial value. This one was my sample. Let's put those together. That was vinegar. This is empty. And then the other thing I'm going to do right now is I'm going to take a piece of paper, just a scratch paper, and I'm looking for a very faint pink color, so I need something to see that with. Okay, so we are ready now. First I'm going to add a whole bunch. Okay, can you see how that pink color? So what I'm looking for is a very faint pink color. If my solution turns that like dark purple color, that's too much. Make sure you have your initial value written down. I wrote it down, and then I'm going to just add to my sample. And as I get closer and closer to the endpoint, there's going to be less and less acid for the base. This is base. I'm adding it to the acid. There's less of the acid in this volumetric Erlenmeyer flask to react with the base that I'm adding. And the indicator, the phenolphthalein indicator, turns pink when there's base present. So that's what's happening. So I'm going to stir. Okay, it's getting kind of close. So you want to get to a point, the instructions tell you want to get to a point so where 1 drop will change the color. We're a little bit of ways, but we're getting pretty close. The first one is probably going to be the slowest. The other way you can do this is you can do a throwaway run. That's what we do in my other classes. You just go really fast and get an idea of how much you have to add, and then be really careful on the next couple runs. So this one, we're getting close. Okay, can you see how that's? So we're getting really close to the color is staying for a long time. There's a drop at the tip, so I also want to get that into my solution because it's counting in my number. Like if I don't get that off, it's still counting in my value. So, all right, I'm gonna keep going. Oops, that was a lot. Oops, we're super close. Oh, I think we're there. Can you see that faint pink color? So and it's staying around for about 10 seconds. If I'm not sure if I'm at the end point or not, but it's like a faint pink color that's fading, I can go ahead and write down the value. So this looks like the bottom of the meniscus is at 11.60. I'm going to write that down as my example. Wherever I put that, here it is. So that would be my final value, 11.60. And if I'm not sure, can you see how it's very faint pink? That's the end point. I don't know if you can see that, but it's still a little bit pink. It's been quite a long time, so I think we're at the end point. We're at equal amounts of acid and base. So then I can use this value to tell me how much acid is in the acetic acid that I titrated. Okay. If I'm not sure, I could write it down and then I could add one more drop and see what happens. See if we can get one more drop. Okay, and then can you see how this really dark purple, that's past the endpoint. So now I've added way more base than acid. These are not equal anymore. Now I have more base. Okay, so you want the faintest pink color. So I would go with my first value. If this was like a really light pink again, I'd probably go with this value now. That was about, now we're at about 11.65. So we want to be as accurate as we can. Okay. All right, questions on that? So then I would do this 3 more times. Let me show you our data table. So we're down here. Got all this stuff in the way. Oh. Okay, so the initial value was 0.6. My final volume was 11.60. So my final volume of sodium hydroxide that I used is 11.6 minus 0.6. So I used 11 milliliters. Okay, so you have to do your own experiment here. Don't copy mine. So then I'm going to have to figure out how many moles of sodium hydroxide that is. So remember in Alex, when we're finding moles of sodium hydroxide, we're going to use concentration. Divided by, the regular one. Concentration is moles over volume. So if we want moles, we're going to do concentration times volume is moles. So we'll have the concentration of sodium hydroxide here, that's standardized. It should be about 0.1, but you're going to check and make sure that whatever I measured out is actually 0.1. And then you're going to times by the volume that you used. Make sure that this is, right now it's in milliliters. You need to convert that to liters so that, remember, concentration is moles per liter. You're going to multiply by liters. That will give you moles. Okay. Then you're going to write down the volume of acetic acid that you used. So we didn't use, so if you follow this procedure, you're going to have to write your own procedure. But what I did was I took 10 milliliters of acetic acid and I diluted it to 100 milliliters. So there's 10 milliliters in the 100 milliliters. And then I took 10 milliliters of that. So I have 10 milliliters in 100 milliliters. And then I took, how am I going to do this? 10 milliliters of that. Of this solution. Of this solution. I'm forgetting how to do the math. Give me a minute. But we have to figure out the volume of acetic acid that we actually used. And then we're going to do the same thing. So we have the volume. We figure out the moles of acetic acid that we used using this equation. Moles. Well, this is also a 1-to-1. So if we have this many moles of sodium hydroxide, this is the same as the number of moles that we added. So if we are right at the endpoint, then one acid will need one sodium hydroxide to titrate, to cancel out. So these will be equal. If I got to the very light end point. If I went over, then that's not true. If we're at the end point where they're equal acid and base, then that's true. Okay, and then we can take the moles. Molarity is moles over liters to get this value. So we just need to figure out the volume. All right, let me do some thinking. So we have our, so we used, we took 10 milliliters and we diluted it to 100 milliliters. And then, we took 10 milliliters of this. Ten divided by 100. Let's go like this. Let me think. So we got 100 milliliters. 10. 10 divided by 100. I will come back. I'm still thinking about that. We'll be able to figure out how much volume we use. It shouldn't be that hard. I'm just having a hard time. How much volume of acetic acid we use, just using fractions, which I have a hard time with. Okay, so the next thing that you need to do is you need to come up with a procedure. So what did we do? I will hand you out a book, and you can use the book from last year as a reference. While we do that, go ahead and pull up the pre-lab for lab 11, and we'll go through that together. If you don't have that, maybe you already have it already. So we're going to Chem 11:15. We're going to Lab 11. We have 2 labs left. That's very exciting. Lab 11 pre-lab. Okay, so while you're pulling that up, I will hand you out a lab book, and you can use it's lab 13 in this lab book. If you all want one, you want to share one. So they need to stay in the classroom unless you check it out. So lab 13 in this lab book. Okay, yeah. So again, you need to write a procedure for lab 13 or lab 11 to titrate the vinegar. So I remember.
What? So we use the lab. Right.
Okay. Pre-lab. Write down the answers so I don't do it wrong. Hi. Oh. Thank you. Thanks. Yes. Yeah. Let me find it.
Oh, you already did that?
All right, so question number 1 is asking, what mass of KHP? This is something that you need to know so that you can do the standardization. You're measuring exactly an amount of KHP. So we have about 0.1 molar sodium hydroxide. We're going to titrate, we want to titrate with about 15 milliliters. So if we use too much, it's going to just take too much sample, take too much time. If we don't use enough, then it's not going to be accurate. If we're using like 1 milliliter to titrate, that's not going to give us like very accurate information. So 15 is pretty good. And I think the lab instructions go over that. All right, so let me write some numbers down. We're using 15, we want to use about 15 milliliters of 0.1 molar sodium hydroxide. So we're asking the question, how much KHP should we measure out? Remember, we're using KHP because it has that one hydrogen that we can figure out how much hydroxide we're using. It's a 1-to-1 ratio. Okay, so we have, we need to figure out, the first thing we're looking for is how many moles of NaOH will that be? So we're going to find moles, and we talked about we're going to use concentration times volume. Volume needs to be in liters. So concentration is going to be in moles per liter, or molarity, which is what it is already. Volume needs to be in liters so that we end up with moles. So we have concentration here. This is the concentration, 0.1 molar, or we can write moles per liter if we want our units to cancel. And then we have 15 milliliters. We're going to convert that to liters. 1, 2, 3 divide by 1,000, 0.015 liters. Now liters cancels, and this is going to tell me how many moles I'm using. 0.1 times 0.015, so 0.0015. And this is moles. Through this whole lab, I will be watching for sig figs, and the pre-lab is also watching for sig figs. So let's see. Let's go back really quick. This one has 2 sig figs. This one has 3 sig figs. So we're going to keep 2 sig figs when we do this calculation. All right. So this is how many moles of NaOH. What we talked about, if we have H plus OH, that gives us water. This is going to be a 1-to-1 ratio for KHP. 1 proton in KHP gets titrated by 1 sodium hydroxide. So that tells me if I have 1 mole of NaOH, that will be the same as 1 mole of KHP. So that is how I'm going to bridge between moles of NaOH and moles of KHP. So this is telling me, well, I have 0.015 moles of NaOH if I use 15 milliliters of 0.1 molar. So that means I need 0.0015 moles of KHP to measure out. Well, I can't measure moles in the lab, so I'm going to convert moles to grams through the molar mass. So I'm going to take 0.015 moles of KHP. I'm going to multiply by the molar mass, which we already looked up. The molar mass of KHP is 204.22 grams per mole. Moles cancels and we get grams. So then we type that in. Okay, I'll let you do that. And then how many sig figs? So we talked about in the question, this one had 2, so we're going to have 2 sig figs. Okay. All right, questions? All right. I feel like you can type it in your calculator. That would be good. All right. Next one is, how much liquid is the pipette designed to deliver in milliliters? The pipettes we have start at 0 and they go to 10. They're designed to deliver exactly 10, and we are going to put 10.00. And we don't have to put units. With this pipette, we are going to get 2 decimal places. I'm watching for that when you write down your numbers in your lab. 2 decimal places. Okay, so then the rest of them are just questions about what's gonna happen if this happens in your lab. So we have to think about what's gonna happen. Consider the following potential sources of error. This one is, there was a little distilled water in the Erlenmeyer flask. So what happens if I wash this but I didn't dry it? Does water have H plus or OH? This water should be neutral, okay? So it doesn't matter, okay? If there's a little bit of water, what we're watching for is if we have to titrate more acid than we think we are titrating, or if we are titrating less acid than we think we're titrating. This just having water in there should have no effect because water is not an acid or a base. Okay? It's neutral. Next one, there was a little acetic acid in the Erlenmeyer flask. Okay, so what's going to happen if we have acetic acid in here? We didn't wash it all out. And then we add our acetic acid in here to titrate. It's going to have a bigger effect. We're going to have to titrate more of this. We're going to need to use more hydroxide to titrate the acid that we think. So that's going to increase it. Okay, next one, question 5. There was a little distilled water in the pipette you used for the acetic acid. You forgot to rinse the pipette with acetic acid. So what are you adding? Are you adding more acetic acid? Are you adding? So you're not adding exactly the correct amount of acetic acid. If there's water in there, you're going to be adding less acid than you think. So then you're going to need less base than you think. So overall, your concentration will end up being too low. Does that make sense? Okay. Question 6. You added 4 drops of the indicator. Does that matter?
Yeah.
This one is not going to affect the concentration. Okay. No effect. The indicator only changes in the presence of base. The indicator doesn't add its own acid or base. Okay, next question. An air bubble is present in the acetic acid pipette, but it stayed in when you measured the acetic acid. So I think that's talking about like at the tip. So you have a little bit of air at the tip, but it stays at the tip. That shouldn't affect it. Oh, let's see. Yeah. No effect. Some of these are less straightforward. Okay, 8. Go back, yes?
I thought you said there was no effect on that.
No effect. Yes, I did see that. Thank you. Yes, good catch. An air bubble was present in the acetic acid pipette and it came out when you measured the acetic acid. So this one's going to make your concentration higher than you thought. Okay, number 9. Okay, while you're titrating, you have already recorded your initial value, and then you scoot your pipette, or you move it for a minute, your burette, and some of the base drips on the counter. The level's going to drop, and then you're going to start your titration. So what would happen if you didn't notice that some base dripped out of the tip? That means you would be adding more base than you think. Or it looks like you're adding more than you think. So your value is going to be too high. Does that make sense? Okay, because you added more base, but you didn't really add all the base. Some got on the counter. Good. Question 10. Okay, there was a pebble at the bottom of the sodium hydroxide burette. So if there's like something stuck here, remember this is measured by difference. So if you start here and end here, it doesn't matter if there's something at the bottom. This is pretty accurate because we're measuring by difference. Like when we measure by difference on the scales at the beginning of the year, that gets rid of some of the error. So it doesn't matter if there's a pebble at the bottom. No effect. And question 11, you forgot to add the phenolphthalein indicator. Oops. You added the indicator once you remembered. The solution remained clear. So you're not at the endpoint yet. Then you continue the titration. Is there gonna be a problem? No, no problem. Okay. If for some reason you forgot the indicator and then you add the indicator and it turns pink, like this pink, that means you're too far. Then you'd have to redo it. Okay. All right, submit. I think I didn't do one of them. So. Okay. Hopefully that went well for you. We have 5 minutes of class left. So take some 5 minutes and work on your procedure for Friday.
What's the test?
The test, I don't know. Let me look. I think it's probably Thursday.
So we'll have a work day?
Yes, we'll have a review day.
Okay.
For chapter 1. Well, chapter 12. It's confusing for more.
Where are we looking here?
Chapter 13. Chapter 13.